Okay, so I have the two equations written out. Now, the second one is simple. It's a one-step equation. There's no number in front of x, and I would just get x equals -4. The first equation, since there's that number in front of x, makes it a two-step equation. So I first add 3 on both sides, which gives me 2x equals 3. And then I'm going to divide both sides by 2 and get x equals 3 over 2. So my solutions are -4 and 3 over 2. Okay. Next one. I have a minus sign in front of the x squared term. So I never want my a, my leading coefficient in front of x squared, to be negative. So what I'm going to do in this case is I'm actually going to add the 36x squared to both sides, giving me 13 equal to 36x squared. I would always put the x squared term before the constant, minus 12. And now I have another step, which I could have done in the same step, of subtracting 13 on both sides. So now I'm actually going to write the right-hand side first, 36x squared minus 25 equal to 0. Now I have the equation set equal to 0. My first thing to do now, or second, is to determine what method I'm going to use to factor. I always look for a GCF first, but there's no number that will divide into both 36 and 25 other than 1. So I see the minus sign, and I see that I have 36x squared, which is a perfect square, and 25, which is a perfect square, so I can get their square roots. Don't forget to get the square root of the coefficients, 6, x, and 5. So my two factors are going to be 6x plus 5 and 6x minus 5. Okay, so that was a little bit more work to get into standard form. You have to make sure that the x squared term is positive. Set each of the factors equal to 0. And both of these have a number in front of x. So I'm going to have two-step equations. 6x is equal to -5. Divide both sides by 6, and x equals -5 over 6. And here I'm going to add 5 to both sides, so 6x is equal to +5, making the solution +5, 6. So I have -5, 6 and +5, 6. You can write the positive -5, 6. You don't have to, especially if it messed you up yesterday. Okay, so here we have one term on each side, definitely not set equal to 0. And you're going to determine which term you're subtracting from both sides to keep the x squared positive. So since x squared is positive where it is, I'm going to minus 10x from both sides. So on the right-hand side, I have 0. On the left-hand side, can I combine 2x squared minus 10x? No, because the first one has the x squared and the second one does not. So I'm just going to write it down as 2x squared minus 10x, two separate terms. So I have the minus sign like the last one, except 2 isn't a perfect square, and neither is 10x. So this is not a dot. Sorry, I just did not mean to do that. 2x squared minus 10x. This is a GCF. What could I divide both 2x squared and 10x by? This was the one that gave you guys a lot of trouble in the homework last night, number 3. Okay, I could divide these both by 2x. The one in last night's homework only had the x you could divide by. So 2x is the GCF. The other factor is the 2's cancel. X squared divided by x is x. Minus here, the x is canceled. 10 divided by 2 is 5. So now I use the zero product property, setting 2x equal to 0 or x minus 5 equals 0. And then I solve each of these equations. Divide both sides by 2, get x equals 0. Add 5 to both sides, get x equal to +5. So your solutions are 0 and 5.